Hi, my name is Morgan Wilson, and I'm a PhD student from the entomology department at Virginia Tech. I'm going to begin by showing you guys the underside of a couch that we pulled from a home infested with bedbugs. And what I want to point out here are the many dark spots. These are bedbug feces of many, many generations. Now, it doesn't take an expert to tell, based on the number of spots here, that this home is heavily infested. But if we were to inspect a home that only had a couple of bed bugs, how much fecal evidence would we find? Exactly how many spots can a bed bug leave behind? And how easy are they to identify? This is why we decided to quantify the daily feces production of each bedbug life stage. Bedbugs are blood-feeding ectoparasites that produce small, smooth feces that adhere to any surface. They are easily recognized as dark fecal spots. However, bedbugs can also produce these light or cream-colored fecal spots that are more difficult to detect. Fecal spots stain furniture and fabrics, so they can be very unsightly. However, feces are important indicators in determining the severity of a bedbug infestation, and they are crucial evidence for litigations. Additionally, a study from the North Carolina State University found that bedbug-infested homes contained high levels of histamines. And these histamines can persist in homes for up to 3 months after a population has been eliminated. So not only are these fecal spots unsightly, but they are potentially a health concern. We had 2 objectives for this study. One was to determine the average number of fecal spots produced by each bedbug life stage. 2, quantify the different types of bedbug fecal spots produced after each blood meal. So the number of light colored poops versus the number of dark colored fecal spots. Our motivations for conducting this study was to be able to walk into an infested apartment or home and get an idea of how many bedbugs there are. We began this study in January 2021. We fed 50 of our Lexate bedbug females and placed them in individual Petri dishes lined with filter paper for them to lay eggs. Before we began the study, 50 eggs, one from each female, was selected and placed in their own Petri dish lined with filter paper and allowed to develop. After the eggs hatched into first instars, we provided them with a blood meal. All eggs and bedbugs were stored in an incubator held at 25 degrees C. After hatching, each bedbug was provided with a human blood meal and allowed to feed to repletion. Each Petri dish had a mesh fabric lid that allowed the bedbugs to feed without escaping. After each blood meal, bedbugs were given new filter paper and fecal spots were counted daily until the next blood meal. Bedbugs were fed when they stopped producing fecal spots. So nymphs were fed every week and adults were fed every 2 weeks. And all bedbugs received a total of 10 blood meals. After collecting filter papers, we counted the total number of dark colored fecal spots and the total number of light colored fecal spots. So this was a very straightforward study. Then one day, strictly out of my own curiosity, I placed a couple filter papers under a long wave ultraviolet lamp or a black light. Holy moly, you would not believe what I found. There ended up being double the amount of spots that there were before. So I found out that not only are bedbugs producing these dark colored spots and these creamy light colored spots, but they're also excreting these clear liquidy spots that we can't detect with our naked eye. Well, clearly that made for interesting results. This graph shows the number of fecal spots represented by the y-axis produced after each blood meal, represented by the x-axis. Each blood meal corresponds with each life stage. So if you look at the first blood meal, that corresponds with the first instars. Looking at those first instars, the first blood meal, there's an average of 8 fecal spots produced. And that increases to 25 fecal spots for the 5th instars. And onward with the adults, fecal spots are in their 20s. Now that sounds like a lot per blood meal, but those were all counted with the naked eye. We look at those filter papers under a black light, There you go. We now have double the amount of fecal spots that there were before. So the first instars, 14 fecal spots. That increases to 46 fecal spots for the fifth instars. And now we have significantly greater number of fecal spots than what I was detecting with the naked eye. This table shows the average number of fecal spots produced per day for each life stage and the duration each life stage spent pooping. So we'll start with the first blood meal. The bugs began as first instars. They did molt, but they still continued to poop after molting. They produced 2 spots per day for a duration of 5 days. That's significantly different from the fifth instars in the adults, who produced about 3 fecal spots per day for a duration of 9 to 10 days. Now, I want to emphasize that these results were determined from counts that were visible to the naked eye. We now know, thanks to the black light, that these numbers are probably much higher. So after discovering these additional clear spots under the black light, I calculated the average percentage of fecal spots produced by each bedbug life stage presented in this graph. The x-axis is the blood meal and the corresponding life stage up top. The y-axis is the percentage of dark in blue, light colored in orange, and clear colored fecal spots in gray. And as you can see across the board, across all life stages, the easily identifiable spots, the blue, only make up about 1/3 of the fecal spots that bedbugs produce. So for the adults, that's about 30%. So while it is possible to see the light colored fecal spots, 30% of the adults, you would have a harder time detecting them unless they were on a light or slight surface or you were trained to pick them up. And you certainly would have a harder time or an impossible time picking up these clear spots, which make up about 40% of the adults' production. So the original goal of this study was to make residents and litigators aware of crucial evidence because bedbug feces are so prevalent. But thanks to the black light, we discovered that many fecal spots go undetected by the naked eye. This is very important because it shows that bedbugs are contaminating way more household items that we may not be aware of. So fecal spots are a reliable form of evidence for identifying bedbug infestations. But keep in mind that we're only detecting about 1/3 or maybe half of the spots that are produced by bedbugs. And when an adult bedbug can produce well over 40 fecal spots after a blood meal, we can look at this bed sheet and realize that we may not fully appreciate the amount of contaminants that bedbugs leave behind. Those dark fecal spots are only a fraction of what is actually there. And on that note, I'd like to thank my major advisor, Dr. Deanie Miller, and I'm welcome to answer any questions that you may have.
So we have a few questions. Is there a difference or known reason for differences in the color that you've determined?
For the percentage of colors?
Why do they differ? Why are some different colors?
As far as the coloring, the dark fecal spots, that's clearly the product of the blood meal. I mean, they are all products of blood meals, but the dark fecal spots is basically they are pooping out blood from their host. Now, the clear colored fecal spots, we're not quite sure what we're looking at there. And the clear spots, not necessarily feces, but there's clearly excretions going on that we previously were not aware of. So one future plan that we have for this study is to analyze the components of these spots that these bedbugs produce.
Sounds like a good plan. I don't think many people in this world are having such an intense conversation about bedbug feces today as we are. So we have some other questions. We can save those for the Q&A if we want to go on to Maria.